Hello, everyone, and welcome to this webinar, very first webinar of the July series. And over the next 45 minutes to an hour, we're going to learn about Corda. We're going to take a deep dive on basically some of the technical features of Corda. And we'll try to understand how it's different from traditional blockchains. So my name is Asutosh, and I'm a developer evangelist at R3. I'll be joined by Sneha. She is again a developer evangelist. We all take care of developers like you. We try and make sure that you have a smooth journey when you start your development with Corda, while you develop your applications on Corda as well as while you try to go into production. So yeah, without much further delay, let's just jump right in. Um, so before we start, do a little bit of an exercise here. Let's do a small poll. Let's try and understand what's the kind of audience that we have got here. So just maybe type in blockchain if you know about blockchain, or type in no blockchain if you don't know about blockchain. So just so that you guys are aware, it takes about 30 seconds for my voice to reach you. That's because of the YouTube streaming thing. So by the time you type in this information, it will take some time for me to read them. Yeah, so it should be about 20 seconds or so. Still waiting. All right, I guess you have it. So we see some people. This one guy who has some knowledge of blockchain. All right, Deepak. Yeah, see a lot of people know blockchain. That's cool. I think we don't have to do a lot of hard work in trying to make sure that you guys understand blockchain as well. But people who do not understand blockchain, there's nothing to worry. We will try to make sure that when we talk about a particular thing in respect to Corda, we'll try to make sure that we do cover a little bit of a background on why we are comparing that particular point of Corda with blockchain. So yeah, let's get some of the housekeeping stuff outside. If you're new to Corda, just join our public Slack. That's where it's a community of around 8,500 people already, all Corda developers. So it would be a great place for you to just join in and probably work with other fellow Corda developers, right? So documentation on Corda is available on docs.corda.net. So that's all and everything that you want to know about Corda is out there. We have a free training site. We just came out in a few weeks earlier, I would say. So just head there to training.corda.net and you get a very well made training where you would start with what is blockchain to learn in-depth knowledge of Corda. So if you're new to Corda or even to blockchain, feel free to just go out there and check out what's out there on training.corda.net. We're developers. Most of us like to see the code, right? So if you're developing on Corda, it's probably that you would like to see how the code has been written, right? So all the code or all the source code of the Corda platform is open source and it's available out there on our GitHub repository. So head out to github.com/Corda and you'll find all the repositories over there. So contact us, the entire Devrel team. So you could basically write to us at devrel@r3.com, or you could tweet us at using @Corda blockchain or @inside R3. Both these are the handles which we at R3 do track, are our handles basically. And do not forget to use the hashtags #Corda or #R3. All right, so let's move on. Okay, so whenever we start a new enterprise, right, we start to do something new. There has to be a belief that we need to have. So what do we believe as we being at R3? What do we believe in, right? We believe in DLTs. Obviously, we believe that DLTs are here to stay, and why not? They do so much. It just transform everything that's happening around the world right now, right? The reduced cost. They just uh, give so much of operational efficiencies. You just can trust all your data, right? You know that whatever data you're looking at is always the same data that others are also looking at. So it just streamlines all your operational things, and that's how it brings down your cost to your time to market, your cost, and as well as increases the entire business processes, right? So when something has so much to offer, why wouldn't it be accepted by the world? We don't see a reason around that why it would fail. But yeah, it takes time. So changes of this big, something that's big when it comes, and when people start to adopt that, it does take time. There's a little bit of a curve over there. But if you have been following blockchain, like a lot of people have told us that blockchain, so you might have been following blockchain for quite some time, and you might know that it's making a great progress, making steady progress. But yeah, it's making great progress over the last few years, and we hope that it will be big in the next few years. So we continue to hope that, and we continue to build Corda with that vision in our mind. We want you guys to share your beliefs. Since you are here, you want to learn about Corda, so we're sure that you'll share that belief with us as well. So let's look at, since this is a very first introduction to Corda webinar, so let's try and look at a little bit of a history of how Corda came into being. So we're not going to go into too much of details around here. We'll not talk in-depth history lessons here. We don't like history, I know. But yeah, let's just have, I will not spend more than 2 to 3 minutes of your time here. So everything just started, the entire story of Corda started back into September 2014. That's where I think the entire Bitcoin and blockchain thing was at its peak, and everybody wanted to do something on blockchain. So what happened is there were all these 8 banks who came together and discuss how they could utilize this new technology that's growing so fast into their own business use cases. And they evaluated a lot of platforms that were out there, and it so turned out that not all of them, I mean, whatever were there were really very fit to do this, to be applicable on business use cases. So so they wanted to build something new, right? So 1 year down the line, all these guys, they agreed to build a enterprise grade solution, especially for the financial domain at that point of time, that could serve their business use cases. And a separate architecture working group was created, which focused on building enterprise grade applications or blockchain applications for finance at that point of time. And then 3 months down the line, this particular small consortium has grown up to, like, it started with 8, and then there were 9 banks who actually joined this consortium, and it's in just a span of 3 months, it just grew to like 42 banks, 42 different members. And 1 year from there, close to 1 year, we had our first release of the Corda open source. And then the work of the enterprise version of Corda, of Corda was also going on. And at the some 2 years down the line, 1.5 years down the line, let's say in July 2018, the first version of Corda open source was out. It was basically Corda Enterprise 3.0, to keep it in line with Corda, with the versioning of Corda, which was just released during that time period. So yeah, that's where the first version of Corda Enterprise came into being, and we never looked at from there. Fast forward 3 years to now, and you could see, fast forward 2 years basically to now, you could see that the entire ecosystem has now grown up to basically about 350 plus members. And that's when I say 350 plus, it's not just financial institutions anymore. It's more of cross-industry collaboration now. The partners are from different industries, and we have moved on from being a blockchain for finance to being something which is more of a general purpose blockchain applicable in every different domain. So if you have a business, and if you have data that is shared across different participants, right, and you have trust issues, you want to make sure that whatever data that you see is valid, and you need to trust that data, then we are pretty much there. You can always trust on Corda to help you in that particular domain. All right, so that's pretty much, like I said, I won't take too much of time of yours in the history lessons. So let's move on. Let's look at a little bit about how R3's partner ecosystem is structured before we dive into the technical things. So we broadly categorize our partners, all these 350 different cross-industry collaborations, into 4 different categories. The first one are our members, like the initial people who joined in as members. These are all the big banks that and all these different logos are out there. Might know a lot of them. So these are our members, and then we have ISVs, who are independent software vendors, who build basically who build products on Corda, like who build applications on Corda, and they sell them. We have delivery partners, who are our SIs, all the big SIs like TCS, Infosys, you take the name, they are there. So that say they deliver services to all our clients. And similarly, we also have infrastructure providers, who something like GCP or Azure or AWS, and these guys provide cloud services. Apart from that, we also have others who would provide other services like HSMs, or you might know about Intel. They provide services in the form of the SGX things, which we are working on um, to bring like multi-party compute into Corda. So if you've heard of, there was a recent beta release of Conclave which has happened. That's based on Intel SGX. So yeah, there are different infrastructure providers which provide different services as well. All right, that's too much of theory thing, and let's just dive into technical things. Let's try and understand how Corda is different from traditional blockchains. We just keep saying this term that Corda is meant for business. What do we really mean by that, right? So first up, let's try and understand what were the problem we talked about when we look at traditional blockchains and try to utilize them onto a business scenarios or business use cases. Well, the very first issue that's quite eminent is the issue around identity, right? If you are familiar with blockchain, you might have just looked at some of the blockchains that are available, like the public blockchains like Ethereum or Bitcoin. And you must know that when you just basically do a transactions, or you're trying to send some Bitcoins or Ethers to someone else, you don't know whom you're sending it to. It's just a pseudonymous key, right? So you don't know who your counterparty is. Just think of this in a business case, right? How would you do business with someone whom you don't know? You have to know someone whom you want to do business with, right? You just can't rely on pseudo-anonymous, just random string of numbers and some characters, right? So that's where we need a prominent identity, which is actually missing in traditional blockchains. The second problem is around privacy. So when we talk about privacy, you could think of it as when you know blockchains are really good in having transparency, but what level of transparency is required in businesses, right? You can't have all the data available to everyone in the network, right? When you do businesses, you have certain data like private data, some sort of confidential data, let's say some patent that you have, or some sort of pricing information which you don't want to share with other participants. So it becomes difficult to work in such a scenario where you have all your data available to everyone around there in the network. So privacy is a very important thing when you think of business use cases. So that's where traditional blockchains, they can't really help you with that, because you put something on these traditional blockchains, it becomes available to everyone out there in the network. There is no privacy as such. So we think of these blockchains, like the public ones, as the version 1 or the blockchain version 1, and then the second or the first generation of blockchain. And then there were effort to make some privacy thing with blockchain that came that we could think of it as the second generations of blockchain. What happened is they made these silos where you could have data within them, and these data couldn't go out of that. It's more like creating, rather than having a global blockchain, you would have, say, like create secret societies and then have all these data within that, not leaving, and that data wouldn't leave that particular society of yours. So that again becomes difficult. You want to have people join in you want to have more partners join in into your business, and then it just keeps growing the complexity of managing these kind of silos, right? So that's where we say Corda is a third generation blockchain. You don't really need these kind of things. We'll talk about that in more details when we go into solving these problems and how Corda tackle these problems. Yeah. The third thing, this is also an important thing, is around finality. Most of you guys know blockchain, so you might have done some transaction in blockchain. Let's say you would have done some things, you have transferred some bitcoins or some ethers to someone. So generally, let's take an example of Bitcoin. The way it works is you do a transaction, and there is a probability that you would receive or the person whom you're trying to send that money will receive it within 1 hour, because there is this concept of blocks. Your transaction needs to be included in a block, and that block needs to be buried under a few other blocks, so that so that you're safe. Your transaction is safe. You can't say that you have an attack on the network. But it you might have just noticed that sometimes it takes an hour, sometimes it takes a little bit less, sometimes even it takes like 2 days, right? What the heck? I mean, it it doesn't tell you when it's going to be final, when that point of finality is, right? And the point is that when you are in a business use case, you need to understand that whether it's 1 day, whether it's 2 days, whether it's 7 days, but you need to tell me a point where my transaction is going to be final. That's not the case with traditional blockchains, right? That's because of this entire block thing. And you know that this block is like a linear thing, right? You can't have branches in there. But what happens, I'm just trying to understand why it takes so much of different timings when you have confirmations of your transactions. That's because when you do transactions in blockchain, your transaction gets included into a block, and that block gets appended into the main blockchain, right? Now consider this scenario: two blocks getting created together. What would happen? You have like tree-like structure. Like you have one block, and then there are two blocks pointing to that same block. It's not linear anymore, right? Your blockchain is like branched out. So to tackle these kind of scenarios, what these blockchains do is they wait when you receive these kind of trees like structure. They wait till one of these trees grow long enough so that they can reject the other branch. So what happens if your transaction comes into a block that is going to get rejected at some point of time? So what happens is your transaction again gets into a pool of unconfirmed transactions. Some miner is going to mine that transaction, include it in a block, and then put it again back onto the blockchain. So that's where it takes varying time to confirm your transactions, because if your transaction has come into a forged block, that means your transaction has to be remined and put onto the main blockchain again. Now consider this thing: you're never sure when your transaction is getting remined, and for the second time, you're never sure that that's going to be included in a correct block. It might so happen that it would get included in a first block again, and then again go back. That same cycle keeps continuing. It's always probabilistic. You're never sure when you're getting when you're getting finality, right? So that's where we say that traditional blockchain, the finality is probabilistic. You could say that it could basically finalize in an hour. It could finalize in 5 minutes. It could finalize in 10 days, but you're never sure. That's where the problem is. You can't do that in business. You need to have a certain deadline where my transaction needs to be finalized, right? That's an issue, like we just explained. And then we have the last thing, quite very much relevant for people like us, developers: ease of use. Now you guys are developers, you know blockchains. You might have just tried your hands on some of them. You might have came across this thing, like you have to learn few new things. Like you have to learn new protocols, you have to learn new languages to be able to develop an application on top of traditional blockchains. That stuff, like there is first you need to learn blockchain, and then you need to learn a particular language to be able to use that particular platform, to be able to write an application on a platform. So you already have a learning curve of blockchain, and then and that new learning curve of learning a new language or protocol that adds up to it, which actually increases the time to market as well. And the problem with that, it's not about learning, but it's also about the amount of resources available. Like a lot of people don't know about these new protocols and languages which has came up before. There is not much manpower. There's not much engineers who know about them. So there's lack of talent as well with these traditional blockchains. So let's move on and try to see how we addressed these problems. First problem we talked about was identity, right? So there was no identity. All you know about your counterparty was a public key, which is just a random sequence of numbers and characters. Not a great thing. But yeah, when you think about Corda, it's not a public blockchain. First thing, it's a permission blockchain. What that means is you can't really go and download Corda and start doing transactions. You can't join a network and start doing transactions just by downloading the Corda software. You need to be part of a network, and in order to do that, you have to go through a KYC process. There is an entity called as a doorman who will provision your access into a particular network. This is a sort of offline KYC process which you will go through, and then once you have done that particular process, you will be provided uh, uh, you'll be provided access into the network, let's say. So that's where you are also during that KYC process. It's not just a public key that you provide, not just your certificates, but you also provide a legal name, right? That's where if you see this network out here, we have three different parties, and then a notary tool. We'll talk about that. But just concentrate on the parties right now. It's not just that they have a public key. Well, they do have a public key because they need to sign transactions. But they also have a legal identity. So if I am Titan Tech and I want to do transaction on this network, I know that there are two other participants, and I know them by their name, right? They are Bay Transcorp and Acme International. They are legal identities. They're not just pseudo anonymous people who might don't really know who they are, do they even exist. But since it's a permission network with well-known identities, you know that these people really exist and you can do business with them. You can trust the network on that. All right, that's the first problem solved. You have the problem of identity solved. Now moving on to the second part where we talked about privacy, right? That's like the main thing about doing a business is privacy. You can't have public data. You can't have everything distributed to everyone in the network, right? So Corda's privacy model works on point-to-point communication. We don't really do a broadcast like traditional blockchains. We don't really want. We don't. When you have a transaction comes to you, you don't just send it to everyone that you know in the network. But rather, the way it works is, for example, if Titan Tech here is trying to do a transaction with Bay Transcorp, for example, let's say they are involved in a sale of a vehicle, then the way this would work is basically the information about this vehicle. Once this particular transaction is completed, this information about the vehicle is only available with Titan and Bay. While Acme being in the network, he will not know anything about this transaction. Neither he would know that there is such a vehicle even that existed in the network. That's because he's not part of the network, and all the data is basically point to point. So two people transacting, only two people will have that data. That's how the entire privacy model of Corda work. And but yeah, if there are, you can have this transaction, like you could have a transaction involving three participants, and then three participants will have that information of the vehicle, and the platform as such will make sure that whenever there is a particular asset that is being transacted and two people are having a view of it, the platform will make sure that both these two guys have the exact same view of that particular vehicle. It's not that one person will see a different information in that asset, and the other person will see different information in that asset. That's where the entire DLT thing comes in. So when two people have the same share an asset, they will always see the exact same information. That's the promise Corda will make. All right, so that's how we take care of privacy. You have private data because you're not sharing with everyone. You're just sharing with people that you want that particular data to know. You're just sharing with people whom you want that they should know about this. So if there is a transaction that you do with any counterparty, that's just private between you and your counterparty. All right, so moving on to the notary, there was this particular component over there, right, which we called as notary. Now this is for the third point, the probabilistic finality, right? We didn't talk about consensus, right? Every blockchain or DLT system should have consensus. So how do Corda manage consensus when the transactions are point-to-point basis, right? So the primary purpose of notary here is to prevent double spend. What do you mean by double spend? Right, just taking this example again. When I say double spend, if Titan is able to sell this car to both Bay and Acme, the same car, then he is able to do a double spend. And this is pretty much possible in a network like this if there is no notary. We'll talk about what notary does. But let's say you have done this transaction, Titan has done this transaction with Bay, he has already sold this vehicle to Bay. But Acme, he doesn't know about this sale because he was not party to the transaction. The privacy model of Corda works that way. If you're not a party, you will not really get any information about the transaction. So if Titan sells this car to Acme, he might believe that Titan haven't ever done a transaction with Bay, right? So in order to prevent this, we have a component, or this particular component, logical component called notary, where through which every transaction should go. So notary is not a single node. It can be, but it's mostly a pool of nodes, multiple nodes running together, providing consensus, providing consensus around whether a transaction is a duplicate transaction or whether a transaction is an attempt to do a double spend or not. So when this transaction comes to the notary, he will make a note that this particular asset has already been sold, and he will not allow any kind of double spending in the network. So every transaction has to go to the notary, and finally, when the notary gives a go ahead, only then that transaction is considered to be valid or finalized. Only then the transaction is basically stored onto the ledger. All right. So now again, the point here is one doubt that people might have, that how do you say that it's decentralized while the notary is looking at everything that's going on? Well, that's not the case. The notary doesn't look at what's happening or what's the data that is being transacted. Well, all the notary have a view of is basically like a very high level structure of the net of the transaction. It will just look at the model of the transaction and identify, like it will just look at the structure of the transaction and identify whether it's an attempt of double spend. I'll not go into too much of details of how that work, but yeah, if you want to know about it, just catch hold of me on Slack. I'll explain that on to you guys. So that's how it works. Notary is the person who prevents double spend onto the network. It tries to keep the network sane, right? It doesn't allow any inconsistencies of data in the network. That's how notary works. And since we are talking about finality here, so notary takes care of the final step of your transactions. When a notary says that this transaction is okay and it will be committed onto the ledger, there's no going back after that. You can't roll back a transaction that the notary has already notarized, which means it's final. There is no thing like probabilistic finality. Notary says final, it is final. All right. The fourth point. All right. So I'm looking at a question called from the audience who says who controls notary nodes. Now that depends on your business network, right? Right. So you will work in a consortium. You'll have your own governance rules. It depends on that. So it might be that a particular network doesn't trust each other. So each of these, let's say 5 nodes who are forming a particular business network or a consortium would say that I don't trust anyone. I want each of these 5 people would want to run one node onto the notary pool. And so there are 5 nodes in the notary, each from each of these participating organizations, and they run their own consensus algorithm. Or there could be other kind of network where there is a central party. Let's say it's a network of banks doing payments and stuff. There is this guy like a central bank who needs to know what's happening in the network. He could serve as a notary. Other models as well, depending on how your business network governance model is structured. Right. All right. Again, just to make sure that notary doesn't see what's happening inside you. It doesn't know what transaction is going on. It doesn't know there is a vehicle being transacted. It knows nothing. All he sees is basically your transaction ID and few numbers and all. I'm not going into too much of details with that because that will require too much of explanation to do. And this is just a very high level introduction to Corda. All right. So looking at the next thing about ease to use, which very much relates to us like developers. So if you're a Java developer and you have worked on relational databases, you've worked a little bit on queues, that's you don't even need to understand how queues work. I mean, if you're doing writing an application on top of Corda, so basically you can write all your applications using Java. If you're a Java developer, that's pretty much enough. You can write a Corda or a Corda application or an application on top of Corda, right? Platform itself is built on Kotlin, but Kotlin again is a JVM language, right? So anything that can be interpreted by JVM or compiled to JVM is supported. So you could use Java, you could use Kotlin. It's up to you. So most of the people use Java because that's the very popular language. So we use all these technologies like Java, any RDBMS. We don't use any fancy database technologies. We use plain simple RDBMSs, which mostly every developers know how to work with. And then this message passing, we talked about multiple nodes interacting with each other. How do they pass message between themselves? For that, we use simple Artemis MQ, which is just a message broker, and that's how we just transfer data among nodes, right? Pretty simple. These are technologies. We have not tried to reinvent the wheel because we don't want to come up with something which, if we can really use something that's already there. All these things are out there in the market for years. They have been tried, proven, tested. Why do we reinvent the wheel? Why do we build a new language to be able to write an application on Corda? You could just use Java. Why not? Right. So that's pretty easy. If you're new to Corda, just try out. It just uses Java. All right. So we pretty much covered all the four major things we talked about. There are more to it. We can talk about it in detail. Just get hold of me on Slack or Sneha, and then we can talk in more details. But yeah, that's pretty much a very high overview of what we did, what are the different things that were considered while we developed, how we try to make it more and more suitable for business blockchains out there, for businesses out there. So four things we talked about: identity. There are no anonymous identity. There is no sequence of there is no the string random string and numbers uh, that you basically interact with or that you do transactions with. These are well-known identities who you know by a well-known legal name. And then we talked about um, and then okay, someone said please share the Slack channel. I think Sneha will ping it to you. It's slack.corda.net. Well, you just type in slack.corda.net, and that will give you uh, uh, a window where you need to type in your email address, and you'll get an invite to join our Slack. All right. So coming back, the next thing we talked about identity. Next thing is privacy. So we talked about it. All our transactions are point to point. There is no global broadcast, so your data is safe. Your data is only known to someone that you wish should know. And then finality, no probabilistic finality. When you say that I'm doing this transaction, this basically I'm doing this transaction and response to the notary, it's final. You don't have to worry about that it will get into a block again and then I'll have to wait for it to get finalized again. That's not happening. Once your transaction has been finalized, it is final. You don't have to worry about that anymore. And then the ease of use, we talked about this. We use Java, we use RDBMS. All these are pretty well known. Almost 90% of developers who work on Java do know RDBMS as well. And that's pretty easy. All of them have been tried, tested, proven. All the enterprises use them, so it becomes really easy for people who are working with these enterprise softwares to basically integrate Corda into their software systems as well, because we use the same tech stack which all the major enterprise softwares use, right? That's pretty much it. I think now from here on, I will pass it on to Sneha. We'll take you through a little bit about Corda network and some of the facts about some of the key concepts and facts about a Corda app. That's how you develop a Corda app, and still take care of you guys from here on. Thank you from me, and over to you, Sneha.
Thank you, Ashutosh. Can you hear me?
Yeah, I can.
Yeah, cool. So yeah, hello guys. So let's move on from here. We had pretty much an overview of Corda till now. So now let's move on to some more details. Let's begin by talking about the Corda network. Okay. So before you would like to deploy your Corda node onto the Corda network, let's talk a bit about Corda network. So this picture, so this picture which you see, it represents the Corda network. So when I say Corda network, I mean the Corda network. So the Corda network is you can say it's a publicly available internet of Corda nodes, and it's typically operated by the network participants. So this network, it went live in December 2018, and it is, as of now, it is currently hosted and it is currently governed, you can say, by an independent non-for-profit organization, non-for-profit foundation. When I say network, there are multiple ways actually to set up a Corda network. So there are three ways. One way is you can set up a local network. To set up a local network, Corda provides you with a tool by which you can set up a local network. Once you set up the local network, you can deploy your Corda nodes individually, and then you can start transacting. The other way is you can join the Corda network. So this is what I just spoke about a minute back about the Corda network. So the Corda network is basically a global network which you guys can join. That's the second option which you have. The third option is you can set up your own private network and have people join to this particular private network. So again, there are different ways to create private network. One of the ways is we have a product called as Cinnamon. We call it Cinnamon, which is CENM, which helps you to set up a private network. So on a very high level, these are the three ways by which you can set up a Corda network. So if you look into the diagram, the green dots, they represent individual Corda nodes or participants of the network. The blue dot represents the identity manager, or you can call it the doorman. So this guy is responsible, this guy or the entity would be responsible to perform the KYC checks for all the parties who wish to join this particular Corda network. After undergoing KYC process for these particular entities, what Doorman will do is Doorman will issue digital certificates. Doorman will issue digital certificates to these legal identities. And after doing that, these identities will kind of get an entry to the network. They will then become visible to other parties on the network. And this is how the nodes can start transacting with each other. So what do you think? What does this offer to you? So this offers complete interoperability. So the nodes would be able to exchange data with each other. They'll be able to exchange assets with each other on a very secure internet layer. So eventually what happens is many networks become part of this Corda network, become part of this global Corda network. So what do we have is essentially we could have a hospital network talk to an insurance network, which let's say in turn, it talks to a reinsurance network. So this is how assets or data can seamlessly be transferred between the nodes. And this is how many networks can be a part of the global network. And this is how different networks can interact with each other. So this diagram also shows that Corda open source and Corda enterprise can also be deployed on the same network, and then these Corda nodes are also completely interoperable. So Corda having Corda open source can interact with a node having Corda enterprise. So moving on to the next slide. Yeah. Ashutosh, can you move on to the next slide, please? Yeah. So now, till now we've spoken a lot about Corda, right? So now let's talk a bit about Corda apps as well. So typically a Corda app is basically Corda app stands for Corda app. It basically stands for Corda decentralized application. So someone may ask you, right, that what is exactly a decentralized application? So a decentralized application, you can say these are compute applications that run on distributed computing system. It is also sometimes referred to as smart contracts in other blockchain community like Ethereum. So essentially what happens is you can think of Corda as an operating system. Rather, you can think of Corda as an Android operating system where so basically what happens is Android provides you the Android operating system, and then Android developers build Android apps on top of this, right? So similarly, you can think of Corda as the operating system. So Corda provides you with an operating system, and then eventually Corda app developers, they build Corda apps on top of it. So this operating system, or let's say rather this Corda platform, you can say, it is packaged inside a Corda.jar. Yeah, so if you click one more time, so what you do is you will build your Corda app.jar, and this your Corda app.jar will have the Corda.jar embedded within your Corda apps. Corda app essentially, it has got three parts to it. It will have a state, it will have a contract, and it will have a flow. We will talk in more details about each one of this in the upcoming slides. Yeah, can you just click one more time? Yeah. So if you look into the diagram, yeah, if you go back. So if you look into the diagram, you would see that each node, so A, B, C are individual Corda nodes. And we've deployed our cordapp.jars individually on each nodes. So each cordapp.jar internally has embedded the cordapp.jar also has embedded this corda.jar also within it. So you can see that each node can also have multiple Corda apps.jar deployed on a particular node. So in real life example, you can say, you can have you can have a supply chain application running on your node. And you could also have an insurance Corda app also running on your node at the same time. Okay, cool. So, till now you might have got a pretty much idea about what a Corda app.jar is. So if you look into this diagram, you could see that we can see that this is a typical Corda network. And over here, we have three legal parties. We have Titan, we have Bay Transcorp, and then we have Colorado. So what is happening is, so yeah, we have Acme as well. So we have Acme, we have Bay Transcorp, and we have Titan. Okay. So what is happening is, so these guys must have undergone a KYC process, and then they must have obtained a digital certificate by the domain. And then this is how the parties have joined this particular Corda network. Now, one obvious question is, Ashutosh just did mention this to you, right? That data is only distributed on the network on a need-to-know basis. So he also touched on a very high level about how double spends are prevented. So what do you think? How do we prevent someone from transferring, let's say, the same digital asset from one party to the other party as well? So how can we basically prevent someone from transferring the same, let's say, the same car to one party and then turning around and also transferring it to other party? How can we prevent this? So as he spoke about this, he spoke about that in public blockchain, what happens is a public global ledger is maintained. And hence each and every participant has a view to this global ledger. And this is how the the entire network participates in the consensus. And this is how everyone knows about everything. So this is how double spends are prevented in public blockchains. But in Corda, double spends are prevented using Notary. So there was a question in the chat asking about does Notary able to see all the transaction details, or how does it prevent double spend? So Notary algorithms, I would say, they are pluggable algorithms, and depending on the use case, you can use either BFT or Raft implementations. So what happens is Notary actually maintains a table. And what it does is, I'm not going to go into much detail, but from very high level, what it does is it saves a hash of the asset being consumed or spent already. So Notary will simply go and check if this asset has already been consumed by someone or not. That is, whether the table consists of an entry of an asset, of this particular asset or not. If it does have an entry of this asset, that means that someone has already consumed this asset, and then it will not sign the transaction and it will simply reject it. So this is how double spends are prevented. Again, as I mentioned, there's just a hash stored in the Notary table, so it doesn't actually see the details of the transaction. So the finality, you can say, as such, is achieved only after the Notary signs the transaction. So looking at this diagram, let's take a very simple basic example. Let's say that Acme and Titan, they want to enter into a deal. And let's say that Acme wants to purchase a car from Titan. And let's say that Titan wants to sell this car to Acme. So Titan wants to transfer the car ownership from Titan to Acme. So as of now, what you'll do without Corda, what you'll do? What they'll do is they'll execute this deal, and this information they'll store in their heads as of now, right? Now, what do you think? How can we model this same kind of behavior using Corda? So this behavior, that is transfer of ownership or selling of car from one party to the other party, as of now using Corda, it can be modeled using three things. It can be modeled using states, contracts, and flows. So these are the three things which are required to model or to build any particular Corda app. So now let's take on a very high level. Let's discuss about how Titan and Acme will proceed and how they'll execute this particular transaction. So what Titan will do is Titan will create a transaction, or in Corda, a transaction is usually called as a proposal. So a transaction is a proposal in Corda. So Titan will create a transaction. It will create a proposal in which he will propose to Acme the transfer of his vehicle. He will also attach a contract which is agreed between Titan and Acme. This contract will have all the constraints and the rules around the car transfer. Titan will execute this contract on his side. And if he thinks that the contract is good, and the contract satisfies all the rules and all the constraints which have been discussed between Titan and Acme, then he'll simply sign this particular transaction using his own key. He will then send this partially signed transaction to Acme. Acme will also do the same thing. Acme will also execute this contract on his end. And if he also thinks that he's also happy, he will also sign that particular transaction. This signed transaction, so this particular transaction, which is signed by both Titan and Acme, and at this point of time, both of them, they have executed the contract on their sides. And then they have signed the transaction. So this particular completely signed transaction will now be sent to notary to check for double spend. And if there is no double spend, then notary will simply sign this particular information or this particular transaction, and this information will get saved on both Titan's and Acme's database. So these series of steps, you can say, is encapsulated in a flow in Corda, with Corda providing many inbuilt flows to perform tasks like signing the transaction or storing the signed transaction by the so once the transaction is signed by the notary, this transaction has to be saved on both the counterparties, right? So this kind of transactions or this kind of steps, there are a lot of inbuilt flows available for you so you can simply use these flows and perform these transactions or perform these steps. Now the contract rules defined will go as a part of the contract. And the information or the fact which parties are interested to save will go into the database. So let's say that you want to save the vehicle number, or let's say that you want to save the date of transfer or the transfer cost, etc. All this information will go as a part of state. So in short, till now what we've seen is how Acme and Titan entered into a transaction, how a transaction was created, and how contract, state, and flow are part of the basic Corda app which you have to develop. So moving on to the next slide. So now if we slightly go into more details about state, contracts, and flows. So I would say that in Corda, all the shared facts, you can say, are part of the state or are called as states. So all the facts or all the information which the parties want to make sure that what you see is what I see will go as a part of state. Corda will always maintain the blockchain guarantee that for each fact shared between two or more parties, those parties will always have the exact same version of the fact. So this guarantee is provided by Corda. For you, from your point of view, you just have to identify what are the shared facts which you are interested to save on the ledger. All these shared facts will go as a part of the state. So there is no need because of this, there's no need for each and every party to maintain its own system of record and engage in costly reconciliation processes, right? So this was about state. So moving on, let's talk a bit about contract. Before I talk about contract, we'll talk a bit about transaction as well in more detail. We saw earlier in the earlier slide, we saw that a transaction is a proposal to update the ledger, or a transaction is proposal in Corda. We also saw that the ledger basically is a set of shared facts called as states. Now, what do you think? How is this ledger updated over time? How is the DLT maintained and how is the DLT updated over time? So nodes update the ledger using transactions. A transaction, as I mentioned, is a proposal, and a transaction is used to modify ledger at any point of time. So a transaction, if you see in the diagram, which is on the right-hand side of the contract, you can see a bigger gray circle, a bigger gray box that represents a typical transaction in Corda. You can see that it has a set of inputs and set of outputs. So a transaction can have 0 or more input states, and it can have 0 or more output states. So what a transaction essentially does is it consumes 0 or more existing on ledger states, and these are called as input states. And a transaction always produces 0 or more new ledger states called as output states. So if a transaction proposal is approved, then you can safely say that the input states have now been consumed, and they are no longer, and now no longer they can be used as input to any future transactions. And if a transaction is approved, the output states, they are created new. So they are created on the ledger, and then they become the current DLT. They become your current state of the ledger. So the output states from previous transactions can then become the input states for future transactions. And this is how transactions are linked to each other. And this is how the ledger evolves over time. So input states are marked as consumed, and output states are the new states created on the ledger. And this is how the transactions chain evolves over time. So now, if you've got an idea about transaction, we'll talk a bit about contract. A contract, you can say, is a function in Corda which simply verifies the transaction proposal. So all business rules, the transaction proposal, you can say, is valid only if each and every business rule or constraint which you have added in the contract is met. Okay, so if each and every contract rule passes, then only you can say that the transaction proposal is valid, and then only you can say that the input is consumed and the new output is created. So in the diagram, if you see, what we are doing is the diagram shows you that there's a transaction and we have one input state and one output state. And what we are doing is we are transferring some cash from Alice to Bob. And if you see in the left hand side, the amount is 3, and in the right hand side, the amount is 999,999. So this is something weird, right? So all these kind of rules can be added in the transaction, or rather in the contract. So what are we doing is we've added 4 rules. We are checking that we are making sure that the transaction should have one input and one output, which is there. The transaction has to be, or the type of transaction has to be a transfer transaction. We are transferring cash from one party to another party. That is there. And we also want to make sure that the value of the cash input equals to the value of the cash output. But this fails, right? Because cash, the input to the transaction is just $3 and the output is $999,999. So this is not correct, right? So this is where the contract will fail. And because of this, the transaction proposal will be rejected. Okay. So because of this, the transaction proposal won't succeed, and the input state won't get consumed and the new output state won't get created. If the transaction proposal meets all the contract rules, then we can consider that the transaction proposal is valid. Once the transaction proposal is valid, we are safe to execute this transaction. And when the transaction is executed, the input, if any, to the transaction will get consumed, and it will be marked as historic, and then a new output state will be created. So this was from what exactly a contract is in Corda. Now let's move on quickly to flows. So the diagram you're looking at, what it depicts is, it depicts a very simple flow in Corda app. So let's take the similar example where Acme wants to transfer the car to Titan. So what Acme will do is, Acme, which is here, let's say node A represents Acme and node B represents Titan. So what Acme will do is, Acme will basically, it will create a transaction. That is, it will create a car transfer proposal. Acme will, if you look at the second box, which says as check update. So after proposing a transaction, it will create, it will verify this particular transaction by running contract at its end. If all the contract rules are met, it will sign the transaction. Once it signs the transaction, it will send this particular signed transaction to Titan. Titan will do the same thing. It will also verify the transaction proposal by running it against the contract. And if all the contract rules are met, it will also sign the transaction and it will send it back to node A. After that, the same signed transaction by both the parties is sent to the notary. The notary will check for double spend, and if there are no double spends, notary will also sign the transaction. And this is how the states will get recorded individually on Acme's and Titan's database. So this was it from a very high level on what a state, a contract, and flow is. So moving on to the next slide, please. So Corda is, I would say, is often released in two versions. So open source is released first, and which is followed by enterprise version. There aren't any much functional differences between both, but it's just like features like HA or performance improvements are done in enterprise version. So you can definitely go and take a look at the open source version on GitHub. There are a lot of samples out there as well. So make sure you go and try them out as well. There was again one question asked about the platform, about the language used. So Corda platform is, I would say it's written in Kotlin, but for writing your Corda apps, you can write your Corda apps in any JVM compatible language. So on GitHub, you could find both Java and Kotlin samples. And so just go and download it and try it out by yourself. So Corda uses an RDBMS to store the ledger. So each node is connected to a particular database, to an RDBMS database. So in this way, if you see, the node abstracts away a lot of complexity of updating a DLT ledger and serves to hide kind of all the horrors you can see of the distributed systems or the cryptography. So let's say that, for example, the nodes helps you with the messaging. So it has an inbuilt messaging framework. It allows you to connect to an RDBMS. It allows you to connect. So by default, Corda uses in-memory H2 database, but you can also connect to enterprise databases like Postgres, like SQL Server, MySQL, etc. Again, if I talk about peer discovery, there are ways where once nodes connect to the Corda network, the peers are discovered automatically. Then the way data is distributed, or the way the concurrency is handled, the way disaster recovery is done for you, or the way you can call inbuilt flows and simply sign the transaction. All of this is taken care for you. So it kind of abstracts away all the complexity around these kind of things. Yeah, so moving on to the next slide. Yeah, so I think we are pretty much done with introduction to Corda. I would suggest that we have these two workshops planned for this month, which is the developers workshop, which is planned on July 23rd. So do make sure you join this. Here, what we'll do is we'll develop a simple Corda app, and all of us will together code it out. We'll do the live coding. So make sure you join this workshop. And we also have a pretty interesting workshop, which is Docker with Corda on July 30th. This will again be same time, like it's going to be 2 p.m. Mumbai local time. And it's going to be on a Thursday. Again, quickly to repeat, do make sure you visit training.corda.net. You'll find a lot of examples and samples, and the training is simply awesome. I also use it for my understanding as well. So make sure you go there and take a look at it. Also, join the Corda Ledger channel. To join the Corda Ledger channel, do visit slack.corda.net. All of us, me, Ashutosh, and all other developer evangelists are available there. So feel free to post your questions there as well. Also, make sure if you have any more questions, you can also post it on the Stack Overflow channel and make sure you tag it with Corda. And also, we have the documentation, which is on docs.corda.net. Also, to keep yourself updated, make sure you hit the subscribe button, and so that you'll get the latest updates of Corda. And again, thank you all of you for joining today's session. So see you all for the next session. Thank you.